this lesson is going to be about multiplication of fraction. Now, usually multiplying is harder than adding and subtracting. However, with fractions, this is exactly opposite. You can see, for example, we are multiplying 2/3, a fraction, a simple fraction, by 1/6. There is no common denominators. All you have to do, you do as it says. You multiply 2/3 by 1/6. The two top numbers, the two numerators, multiply and go to the top of the new fraction, answer fraction, and the two bottom numbers multiply and go to the denominator of the bottom of the answer fraction. Now, the reason I didn't write 2 and 18 is because I'm hoping to cancel if anything can be cancelled at this stage. Any number at the top with any number at the bottom may cancel. Never two together at the top or together at the bottom. So a number from the top with another number at the bottom. 2 and 3 do not cancel. What about 2 and 6? Yes, they both can be divided by 2, so we are simplifying 2/6 to 1/3. 1 and 3 don't cancel. You can use these numbers again to cancel, but there's nothing else to be cancelled. So we have 1 times 1, we calculate now. And 3 times 3 is 9. As simple as that. Let's have another one. 5/6 times 2/15. Okay, as I said, it's simple. The two top numbers, the numerators multiply, go to the top. Denominators multiply, go to the denominator. Some people work out and simplify at the end, but I think simplifying before the end is easier. Now, any top number with any bottom number. Yes, 5 and 15 can cancel. 5 into 5 once. 5 into 15 3 times. 2 and 6 can cancel. 2 into 2 once. 2 into 6 3 times. So here we have 1 times 1, which is 1, and 3 times 3, 9. Another one, 5/12 times 3/4. Very simple, much easier than adding and subtracting. 5 times 3, 12 times 4. So if you don't simplify here, you end up with 15/48 to cancel. Where here it's easier to cancel at source first. So here we go 3 into 3, 3 into 12. 5 and 4, and 5 and 4 do not cancel. So we have 5 times 1, 4 times 4, and the answer is not top heavy, is simple, is proper fraction, and cannot be simplified any further, and that's the final answer. Let me take you to mixed numbers now. 1 and 5/6 times 2/3. So one mixed number, one normal fraction. As I said, you cannot deal with mixed numbers when you multiply and you divide. So all mixed numbers need to be changed to improper or top heavy. If you remember, the number outside, multiply the bottom number. 1 times 6, 6, add to the top. 1 times 6, 6, add 5 makes 11/6 times 2/3. Okay, we write 11 times 2 at the top and 6 times 3 in the denominator. Would 11 and 6 cancel? No, 11 and 3 don't cancel, but 2 and 6 do cancel. 2 into 2 once, 2 into 6 3 times. 11 times 1, 3 times 3. Okay, that's the final answer, but it's improper fraction. The top is heavier than the bottom. So how many 9 cannot fit into 11? Once, remainder 2, same denominator. Next question. 2 and 4 ninths times 3 eighths. One of them is mixed number, so that has to change to 2 times 9, 18, add 4, 22 over 9, times 3 eighths. Now we perform the multiplication. 22 times 3, 9 times 8. 22 and 8 can cancel. They're both even numbers. Divide by 2, divide by 2. 3 and 4 don't cancel, but 3 and 9 cancel. 3 into 3, 3 into 9. So we have 11 times 1, 3 times 4, 12, and this is not top heavy and cannot be cancelled any further. Let's do a question where they're both mixed numbers. 2 and 3 sevenths times 3 and 1 sixth. Mixed number. 2 times 7, 14 at 3, 17 over 7. 3 times 6, 18 at 1, 19 over 6. I repeat, 2 times 7, 14 at 3, 17 over 7. 3 times 6, 18 at 1, 19 over 6. Here we go. 17 times 19, 7 times 6. You can see that in this question, 17 and 7 don't cancel, 17 and 6 don't cancel, 19 and 7 don't cancel, 19 and 6 don't cancel. So we need to just work it out. 17 times 19 is 323, and 6 times 7 is 42. Question is, how many 42 I can fit into 323? It's 7 times. Remainder and 29 over 42. Now, of course, you can use the calculator for this one. Let me just show you how the calculator is done. If you want to enter 323 over 42, you've got a fraction here. Press the equal sign. Now, to convert this into mixed number, shift S to D, and 7 and 29 over 42 is recorded. Okay, next question. 3 and 4 ninths times 1 and 7 eighths. Both mixed numbers. You need to change them both to improper fraction or top heavy. 3 times 9, 27. 27 at 4, 31 over 9. Times 1 times 8, 8 at 7, 15 over 8. Equals. The two numbers multiply to go to the top. The two bottom numbers multiply to go to the denominator. 31 and 9 and 31 and 8 do not cancel, but 15 and 9 Both can be divided by 3. Divide by 3, divide by 3. So we have 31 times 5, which is 155, over 3 times 8, which is 24. Okay, you can either do this by hand or use the calculator. 155 over 24. Right. In order to change it to mixed number, shift S to D button. So the answer 24 into 155 gone 6 times with the 11 remainder. Now, what if you're multiplying a number which is not a fraction by a fraction? Say this. Well, you can always make your number to a fraction by giving it a denominator of 1. Then becomes multiplication of 2 fractions. Never the numerator, but a denominator of 1. Because 5 divided by 1 is 5. So 5 can be written as 5 over 1. So 5 times 2, 1 times 3. That's 10 over 3. Because nothing cancels here. 3 into 10 goes 3 times. And 1 left. Because 3 is 9. 1 left. Sometimes they don't use the word times. They use of. For example, they ask you to find 3/4 of 28. 3/4 of in maths means times. 3/4 of means 3/4 times 28. So remember, of means times. In maths, of means times. Now, I've got a fraction, I've got a number which is not a fraction, and I'll make that to a fraction. So we have 3 times 28 at the top, 4 times 1. 4 and 28 cancels. Nothing else cancels, so we have 3 times 7, 21. 1 times 1 is 1, and obviously 21 divided by 1 is 21. So 3/4 of 28 is 21. Of means times. Another example of, say you have 4/5 of a quantity or a number, 15. Very simple case. Okay, 4/5, remains 4/5. Of means times. And 15 is written as 15 over 1. So we've got 2 simple fractions to multiply. 4 times 15 and 5 times 1. Here, fortunately, 5 and 15, 1 from top and 1 from bottom cancels. Nothing else cancels. 4 times 3, 12. 1 times 1, 1. 12 divided by 1 is 12. So 4/5 of 15 is 12. Now, more awkward situations. Say you want to find 2 1/3 of 4 1/5. But again, of means times. All of these need to be replaced. 2 times 3, 6 at 1, 7/3. Of means times. 4 times 5, 20 at 1, 21 over 5. So normal multiplication, 7 times 21, 3 times 5. 7 and 3 don't cancel, 7 and 5 don't, but 21 and 3 do cancel. 7 and 5 don't cancel, so nothing else cancel from top and bottom. 7 times 7, 49. 1 times 5, 5. So 5, this is top heavy. 5 goes into 49 9 times, because 9 5 is 45, and 4 left. So 2/3 of 4/5 is 9 and 4/5. We are going to the last part of 4 rules of fractions, is the division of fractions. Let's have a simple one. Say 2/3 divided by 4/5. There is no such a thing as division in fractions. You never actually use the division. So the procedure is you keep, change, and flip. So what does that mean? Keep, K for keep. So that means 2/3 remains 2/3. Then you have to change the divide to times. So that's your change. Keep, change. So that becomes times. Divide becomes times. And then flip. Don't mix up with KFC. It's KCF. KCF. Flip. 4/5 becomes 5/4. You turn it upside down. You flip it. As you can see now, it's a multiplication. No division involved. Keep, change, flip. Keep, change, flip. So we do the multiplication now. 2 times 5. 3 times 4. 2 and 4 cancels, because we can cancel. 3 and 5 and 2 don't. 1 times 5. 3 times 2. It cannot be simplified, and it's not top heavy. Let's do more difficult one. Say you divide in 2 and 2/3 by 1 and 1/5. We have a few problems here. Both numbers are mixed numbers. Cannot deal with mixed numbers. Got to change to improper fraction, and also we need to change the divide, but in the right order. First, change them to improper. 2 times 3, 6. Add to 8/3. Still divide. We are not ready to divide yet, because the second fraction isn't ready. 1 times 5, 5. Add 1, 6/5. Now we are ready to divide. Keep. So that's 8/3. We are keeping it. Change. So that becomes times. And flip. Oops, that should be red, but doesn't matter. 6/5 becomes 5/6. Then we multiply. Two simple fractions to be multiplied. 8 times 5. 3 times 6. Remember to simplify here, otherwise you have to simplify at the end, and it's not going to be as easy. 6 and 8 cancel. 2 into 6 goes 3 times, and 2 into 8 goes 4 times. 4 and 3 and 4 and 3 and 5 and 3 and 5 and 3 don't cancel. So here we go. 4 times 5, 20, and 3 times 3 is 9. Nice top heavy. 9 into 20 goes twice. 2 9 is 18. Remainder 2, same bottom number. If if you remember, we changed improper fraction to mixed number by asking how many 9 fits into 20. 9 into 20 goes twice. 2 lots of 9 is 18, so we've got 2 left. And the same bottom number. So 2 lots of 9 with the remainder of 2. Remainder and the same denominator. Let's have some more examples of division of fractions. Start with simple ones. 3/4 divided by 9/16. You remember now? Keep, change, flip. Keep. Change. Change, divide 2 times. Flip. 9/16 becomes 16/9. Now, this business of flip, in maths we call this reciprocal. Reciprocal of 2/3 is 3/2. So when you flip, reciprocal of 4, of course I can't turn 4 upside down unless I give it a bottom number of 1 first, is 1/4. Reciprocal of A/B is B/A. Reciprocal of x, if x is written as x/1, becomes 1/x. So flip, the proper name for it is reciprocal. Sometimes you're asking the exam, what is the reciprocal of a fraction or a number? So you need to know reciprocal is that flip. Reciprocal means flip it. So let's go back to our question now. 3/4, keep, change, flip, which I've written. Then we have 3 times, let me write it here. 3 times 16, 4 times 9. 3 and 9 cancels. 4 and 16 cancels. So we have 1 times 4, 1 times 3. Top heavy, 3 into 4 goes once. Left with 1 over the same bottom number. Let us do 4 more examples of division of fractions to make you feel comfortable. Start with the reasonably simple ones. 2.5 divided by 1/3. So keep. 2 times 2, 4. Add 1, 5/2. Now I'm ready to divide. Change. Divide becomes times. And flip. You turn the fraction upside down. It's a 1/3. We have 3/1. Then becomes normal, easy fractions to be multiplied. 3 times 5 or 5 times 3. 2 times 1. 5 and 1, 3 and 2, 3 and 1. Nothing from the top and bottom cancels. 5 times 3, 15. 2 times 1, 2. Top heavy. 2 into 15 goes 7 times. 2, 7 is 14. From 15, only 1 left. Same denominator. Next one. 2/3 Divide by 3 2/5. Yes, you can divide a small number by a bigger number. So the answer is going to be a much smaller number. Keep. Change. Flip. But we can't flip yet because I have not made this into a mixed number yet. So in this case, it's still going to be divide. I did that on purpose. So when you get here, you're not ready to divide. So here, 3 times 5, 15. Add 2, 17/5. Now, keep. Now change. And now you can flip because you got an improper fraction or a fraction which is not involved with mixed numbers. So that becomes 5/17. 2 times 5, 3 times 17. 2 and 3, 2 and 17, 5 and 3, and 5 and 17. None of them cancel. 2 times 5, 10. 3 times 17 is 51. That's your final answer. Now, let's do a practical question. Say you got a piece of wood which is 4 3/4 of a meter long, and you want to divide this into pieces which are 1 1/6 long. You want to know how many pieces of that size you can get. So both numbers need sorting to the top heavy. 4 times 4, 16. Add 3 is 19/4. Divide. We are not ready yet. 1 times 6, 6. Add 1, 7/6. Keep. That's 19/4. Change and flip. So we have 19 times 6, 4 times 7. 4 and 6 cancelled. So we have 3 lots of 19, which is 57. 2 times 7, which is 14. Now, 14 into 57. 4. The 4 lots of 14 is 56, and 1 left. So that means I can cut full 1 1/6 from 4 3/4 piece of wood, and with a bit left over. So I can cut 4 full pieces of 1 1/6 with a bit of left over. Now we have reached the end of our lessons on multiplication and division of all type of fractions, easy ones, mixed numbers. Introduce the word reciprocal, which is inverting or flipping a fraction. I hope you've enjoyed learning this, because my aim really is to make maths as enjoyable as possible for you. Once you enjoy something, you learn it much, much better. Thank you, and see you next lesson. By the way, next lesson, I'm going to explain fully the rules of directed numbers, which is, I think, is the basis of algebra. If you know the directed numbers, the negative numbers, positive numbers, when you multiply them, it's a different rule. When you add them, it's a different rule. So that's going to be explained next lesson in full. See you next lesson.